This is from your reader, right? The central question is still the same today as it was for our last one. And now we're over here into a problem that has an extraneous solution. And I've got this thing actually teed up right over here. And we'll go ahead and get started. Okay, so this thing looks kind of nasty. But, sorry. Cool. It's not that bad. What we need to do is factor, and there's actually some tricks involved in this, right? So remember I said when we were solving these, the first thing we need to do is find our common denominator, right? So what is our common denominator? And it turns out that if you've got some quadratic expression down here in this denominator, you'll normally be able to figure out what your common denominator is by factoring this thing. So let's go ahead. We're going to write this. Where we're headed with this problem is to be able to write this expression over here on the right side of our equal sign with the factored form in your denominator. So let's go ahead and just recall how to factor x squared minus 8x plus 15. So we're going to factor this thing. Remember what we would do? We would get out this x and we would say, hey, we put the 15 on the top. And we put the negative. Disconnected. All right. So as I was saying, put the 15 in the top, the negative 8 in the bottom. And then I need to think of two numbers such that when I multiply them, I get 15. But when I add them, I get negative 8. And those two numbers are going to be 5 and 3. And I think they're both going to have to be negative, right? So we'll have negative 5 plus negative 3 is negative 8. But negative 5 times negative 3 is positive 15. So when we factor this thing, then we rewrite it as x squared minus 5x, right? That's the minus 5 there. Minus 3x using this negative 3. Right, and we haven't changed it, right? Because negative 5x minus 3x is negative 8x, right? If we're going back up that way. Okay. Then we factor an x out of here, and we factor a negative 3 out of here. Sorry, that's supposed to be a 15. We factor a negative 3 out of there, and then we factor the x minus 3 out and the x minus 5. And so that has been factored. So then we can say that this denominator is actually x minus 3 times x minus 5. And did you see there was probably a little hint as to what this would factor into? Look, the factors are sitting right there. So that's a good way to check if when you're doing these, if when you factor, you don't get the same thing as you had in your denominators of your other two terms, then I would go back and check the factoring. So it turns out that that factored form is also going to be our common denominator, right? Because x minus 3 times x minus 5 is divisible by both x minus 5, right? So it's divisible by this one, it's divisible by this one, and it's divisible by that one. And so that is our common denominator that we're going to use when we multiply through. So remember, so step 1, find the common denominator. Step 2, we're going to multiply everything by that common denominator. So x minus 3 times x minus 5 will go here. And now we got to multiply that through, right? So we're going to multiply all of these numerators by x minus 3 times x minus 5. So 1 times x minus 3 times x minus 5 is just x minus 3 times x minus 5. So that's what's going to land up in our numerator. Over here we have x times, right? We're multiplying everything. X minus 3 times x minus 5, all divided by x minus 3 times x minus 5 equals. And, well, I think I'm going to have to get rid of some of this factoring work over here. Hopefully you have it in your notes. I'm going to show you a quicker way to do that too. So then 2 times x minus 3, when we multiply this, times x minus 5, all divided by x minus 3 times x minus 5. Okay. Why did we do that? Because we're going to be able to cancel a whole bunch of stuff. And we're going to get a much easier equation to work with. Check it out, right? X minus 5 over x minus 5 is 1. Those cancel. X minus 3 over x minus 3 is going to cancel. I'm sorry. This denominator, my bad. This denominator should not have an x minus 5 in it. I got carried away. Right? The denominator here is x minus 3. Sorry about that. I got carried away writing x minus 3 times x minus 5. Sorry. So these are going to cancel. And then over here, these two are going to cancel. Because we just got a bunch of 1s there. We'll drop down everything that we have left. We have an x minus 3 from the first term. And then in the second term, we have x times, we still have this stuff here though, right? So we have x times x minus 5 here. And then this one's just going to be 2. Look at that. That just became so much easier. And the trick is multiplying through by the common denominator. That's how you make these things easier. Okay. Now my task is to distribute, combine like terms, and solve. So because I can distribute this x, I will. So x times x is x squared, it's positive. X times negative 5 is negative 5x equals 2. We got to combine like terms, right? I've got an x and a negative 5x, and I can combine on that side. At the same time, I'm going to move the x squared out to the front so that this thing is in standard form. So x minus 5x is negative 4x, right? And then I've still got to drop down the 3. So we drop down to the x squared, and now we're going to drop the 3. Just dropping them. Are they hot? I don't know. I dropped it anyways. Okay. Subtract 2 from both sides, right? Because now we need to set this equal to 0, right? Set equal to 0. That's what we need to do next. In other words, we got to have all the stuff on one side and 0 on the other side. So subtract 2 from both sides. And I get negative 5. Okay, so it looks like we have a quadratic equation that we need to solve. We have two options. We can try to factor it, or we can use the quadratic formula. I think the quadratic formula is more work than factoring, and I don't like to do more work than I have to. So let's factor this thing. And now I'm going to show you a little shortcut, little factoring shortcut. If the coefficient, right, if this is 1, right, if there's not a number out there, cannot be a number. In other words, A has to be 1. Then you can take this shortcut. Put the negative 5. We'll set up the x just like we normally would, right? Negative 5 on the top, negative 4 on the bottom, right? C on top, B on bottom. And I need to think of two numbers such that when I multiply them, I get negative 5. But when I add them, I get negative 4. Those two numbers are going to be negative 5 and 1. Okay. Check it out. You know that when you factor this thing, the whole point is to make it look like that, right? There's always an x out in the front. I'm going to tell you that all you got to do is put this number right here. And this number, right, it's positive right there. And it's factored. Done. So that is a shortcut way to do it, but it only works, again, only will work if you got a 1 there and not a number. So what does this tell us? This tells us that the solutions are x equals 5 and x equals negative 1. But we have to be careful Because remember, I told you that it's possible that these solutions don't work. It's possible that when I plug them back into my original equation, I wind up dividing by 0, which is just not allowed.
Mr. Dorman?
Yes.
You got the symbols on the x's wrong on the very last part. It's supposed to be x equals -5 and x equals 1, not -1, 5.
So actually, they're right. No, I really appreciate that, and I'll point that out. I'll point out why. And I really appreciate questions and comments. It's awesome. When I plug this in here, right, I get 0. Yeah. So let's imagine that happens. If I plug that in, I wind up with 5 minus 5 times x plus 1 equals 0. So right, that's 0 times x plus 1, which is 0, right? If I distribute the 0, I get 0. 0 equals 0. So that shows me that that is a solution, because when I plug it back in, I get a true statement. And you would find the same thing is true if you plug that in there, if you plug the -1 as well. I love that you spoke out, because I mean, I do make mistakes. So keep your eye on me. I love that you're keeping an eye on me. It's awesome. Okay. Now, I have to check this out. I have to check each of these solutions. So I got to plug them back in and see if I wind up dividing by 0. So all the way back up here to our original equation. And I got to think, okay, if I plug 5 in here, right? So when x equals 5, we divide by 0, which is a no-no. Okay. So that means that x equals 5 is an extraneous solution. So it's not a solution. Even though when we solve it, it comes out as a solution, it's not a solution. It's extra. It's extraneous solution. Ooh. So the only solution is x equals -1. And sometimes you'll be asked a question. I've seen it on the park exam where they had the students solve one of these and didn't ask for the actual solutions, asked for only the extraneous solution. Kind of an interesting way to formulate that problem. So that means that our only solution is x equals -1. Any questions, comments, concerns? Okay, word up. Let's go. We'll do another one then. Another one? Another one. Just kidding. You smart. Real smart. Okay. All right, let's do another one. This one shan't take as long because we know what to do now, right? So let's go through the steps. I got to find the common denominator. And it's probably going to be the case that it's going to be the factored form of what's there. I'm going to say that you could probably look at these and guess that it's going to be like this. But let's check. Let's make sure, okay? So let's factor x squared minus 2x minus 3. So I need to think of two numbers such that when I multiply them, I get -3. And when I add them, I get -2. Those are going to be -3 and +1. And indeed, there's your -3, +1. It worked. These problems are sometimes a dead giveaway. You don't really have to factor them. It's good to check though, because maybe you got one that was a little nastier. that wasn't cool like that. All right. So now that we've established, sorry, I'll write this over here so that it's not in the way. So -3, a -2, a -3, and a 1. All right. Now that I've established that my common denominator is the same as that factored form, common denominator is x plus 1 times x minus 3. Now I'm going to multiply everything by the common denominator. Oh, and hey, I meant to mention it at the beginning of class. I was having awful issues with Savas yesterday afternoon, and it wasn't letting the students that I assigned. So I have first period do the same lesson as we're doing today. I assigned them the assignment that you're going to get today, and it wasn't working. Savas was broken, so I had to like redo the whole thing again. The person who made the assignment sent me a brand new copy, and that wound up working. But when it got sent to me, it assigned to everyone. So sorry that you got assigned today's assignment prematurely yesterday. We're trying to work out things with Savas. I eventually took it down. I saw that it had assigned it to you, and I took it down. I'll be putting it back up today. So if you are one of the people that had a look at the assignment that was assigned yesterday, you'll see that it's going to be the exact same assignment today. And sorry that that threw you off if it did. But we got it all working now. Okay, time to multiply. So I'm going to multiply each of my numerators by x plus 1 times x minus 3. So this is going to be an x plus 1 times x minus 3 up here because we're only multiplying by 1. Not going to change a thing. Over here we have x times x plus 1 times x minus 3. All divided by x plus 1 times x minus 3 equals 5 times x plus 1 times x minus 3, all divided by x plus 1 times x minus 3. Now, after you see these a few times, you might see a pattern that starts to form, right? These cancel. Dang it, I did it again. I get all carried away with writing that. Sorry, this is an x minus 3 only. Good grief. All right, so these are going to cancel, and these will cancel. So I've definitely seen students who were able to skip the step I just did and go straight to the step that I'm doing. They kind of can see that every time this pattern emerges that the denominator cancels, right? And what's left is what's not in your denominator. So if you see that, that's fine. All right, I'm with that. Okay, let's distribute, combine like terms. So x times x is x squared, and x times 1 is x. I'm going to go ahead and rearrange this thing, put it in standard form, and combine these like terms. We've got an x and an x. That's 2x minus 3 equals 5. Now, we've got to set this thing equal to 0. X squared plus 2x. Right? Subtract 5 from both sides. Minus 8 equals 0. It turns out that this is indeed factorable. And I just really need to think of two numbers such that when I multiply them, I get -8. And when I add them, I get 2. Those numbers are going to be +4 and -2. You see what I did there? I skipped the x altogether. That means that we have solutions x equals -4 and x equals 2. Cool. But that's not all. If you act now, we'll throw in a freaking knife. No, not actually. What we need to do is check for extraneous solutions. That's what's not all. All right. So if I plug x minus 4 in here or in here, do I wind up dividing by 0? No, right? -4 minus 1 gives me a -3, and -3 minus, or -4 minus 3 is going to give me -7. So this one checks out. How about 2? If I plug 2 in here or in here, do I wind up dividing by 0? No. So this one checks out. I like to put a check mark when I'm solving rational equations so that I know that I checked. Because if I say that an extraneous solution is a solution, I will get it wrong. So it's very necessary to check. Whoops. Okay, here we go. So like I see something that can be factored. Let's factor it. This turns out to be difference of squares, which follows formula. Let me write down that formula just for grins. It turns out that it is a minus b times a plus b, right? It's just a rule. It's a rule we learned about before. And so I'm going to factor it using that concept. And what, lo and behold, right? The factors of this expression are the same as the denominators that we have over here. You're going to see that's going to happen a lot. So that means that our common denominator is x plus 2. I'm going to write it down just to be thorough. Our common denominator is x plus 2 times x minus 2, which is what we're going to be multiplying the entire equation by. Okay. And we'll distribute. We'll wind up with x plus 2 times x minus 2 in your numerator, divided by x plus 2. Over here you have x times x plus 2 times x minus 2. All divided by, I'm not going to mess it up this time, x minus 2. I did it. Okay. And then this one will be 2 times x plus 2 times x minus 2. All divided by x plus 2 times x minus 2. Okay. I think everything looks right. Now it's time to cancel. I kind of really enjoy that. I don't know why. You know, hey, tell these things to go away. And then we drop down what we've got left. X minus 2 plus x times x plus 2. Right? That's what's left over there in the second term. And over here on the right side of our equal sign, all we've got left is a lonely 2. It's time to distribute and combine like terms. First, the distribution part. X times x is x squared. X times 2 is 2x. Boom, shakalaka. Let's go ahead and combine like terms. I've got an x and a 2x that can be combined. I'll put the x squared down front so that it can be in standard form. Okay. Now I just need to set it equal to 0. And I have to scroll a little bit right here. Okay. X squared plus 3x minus 4 equals 0. And I would love it if this was factorable. I'm going to pretty much guarantee you it's going to be. So I need to think of two numbers such that when I multiply them, I get -4. And when I add them, I get +3. I'm going to put those two numbers in the blank spots. Those two numbers are going to be 4 and -3. So +4 -3. So that means that our solutions are x equals -4 and x equals +3. But that's not all. We've got to go back and check and see if those are actually valid solutions, making sure they're not extraneous. So if I put -4 in there or in there, do I wind up dividing by 0? No. Check it. If I plug a 3 into either of those, do I wind up dividing by 0? No. It's been checked. Awesome. And there you have it. Yep, and in the famous words of Forrest Gump, that's all I have to say about that.